Have you ever stopped to think about numbers? They're everywhere, from the money in our wallets to the code running our phones. But where did they come from? It's a story that starts not with mathematicians in grand libraries, but with our earliest ancestors, looking at the world around them and feeling a new, fundamental need. The need to count. 0, 22. Imagine a world without numbers. How would you know how many sheep you own, or how many days until the next full moon? This was the reality for early humans. The first step towards counting wasn't writing down symbols. It was much more direct. People used their fingers, stones, or notches carved into bone. One of the oldest examples is the Shango bone, found in Africa. It's over 20,000 years old, covered in carved tally marks. We do or not know for sure what it was used for, maybe tracking lunar cycles, or just simple counting, but it shows a mind beginning to grasp the concept of quantity. 105. This simple one-to-one correspondence, one notch for one thing, was a huge leap. It allowed people to keep track of items even when they weren't physically present. A shepherd could use a bag of pebbles to ensure all his sheep returned from the pasture. Each morning, he'd take out one pebble for each sheep that left. In the evening, he'd put one back for each returning sheep. Any pebbles left in his hand meant missing sheep. This was the birth of accounting, long before coins or spreadsheets. 142, but tallying has its limits. Imagine trying to represent 1,000 with 1,000 notches. It's impractical. As societies grew more complex, they needed a more efficient system. This is where the magic of abstraction begins. Instead of just marking 101, ancient civilizations started creating symbols for groups of numbers. This is the dawn of numeral systems. 212, let's travel to ancient Mesopotamia, the land between the Tigris and Euphrates rivers. Around 4000 BC, the Sumerians were brilliant innovators. They were traders, farmers, and city builders, and they needed a way to manage their booming economy. So, they developed one of the earliest known writing and number systems. Using a stylus, they pressed wedge-shaped marks into wet clay tablets. 244, the Sumerians, and later the Babylonians, used a base 60 system. Think about that for a second. We use base 10, likely because we have 10 fingers. But base 60, why? Well, 60 is a fantastic number. It's divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This made dividing goods and calculating fractions incredibly easy. And their legacy is still with us. There is 60 seconds in a minute and 60 minutes in an hour. Why does a circle have 360 degrees? We have the Babylonians to thank for that. 328. Meanwhile, over in Egypt, another great civilization was building pyramids and developing its own unique way with numbers. Around 3000 BC, the Egyptians created a hieroglyphic system. It was based in Hust like Ors. They had a symbol for 1, a single stroke, a symbol for 10, a heel bone, a symbol for 100th, a coil of rope. 1000 was a lotus flower, 10,000 was a bent finger, 100,000 a tadpole, and 1,000,000 was a god with his arms raised to the heavens. To write a number like 276, they would just draw 2 coils of rope, 7 heel bones, and 6 strokes. It was straightforward, but could get a bit long. 418. The Egyptians were practical mathematicians. They used their number system to calculate taxes, measure land after the Nile's annual flood, and engineer marvels like the Great Pyramids with breathtaking precision. Their geometry was born from the need to solve real-world problems. 442 now. Let's journey across the Atlantic to the Americas, where the Mayan civilization developed one of the most sophisticated number systems of the ancient world. They used a base 20 system, possibly counting on both fingers and toes. But their greatest innovation, something even the brilliant Romans missed, was the concept of zero. They had a symbol for a top in a shell. This was revolutionary. 515-0 is more than just nothing. It's a placeholder. In our system, how do we know the difference between 52 and 502? It's the 0. Without it, positional notation where the value of a digit depends on its position is impossible. The Mayans understood this. Their invention of zero, independently of the Babylonians who had a placeholder but not a true number zero, allowed them to make incredibly complex astronomical calculations and create calendars of stunning accuracy. 551, speaking of the Romans, their numerals are still familiar to us today. We see them on clocks, in book chapters, and on buildings. Roman numerals I, V, X, L, C, D. They were dominant in Europe for centuries. They were great for recording numbers, but terrible for doing arithmetic. Try multiplying 123 by 47. It's a nightmare. The system lacked a zero and was not positional, which made calculation a job for experts using an abacus. 6 to 9. So where did our modern numbers, the ones we use every day, come from? The story takes us to India. Around the 7th century AD, Indian mathematicians developed a system that had it all. It was Bastin, it was positional, and it had a true zero. The symbols they used are the direct ancestors of our digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This system was elegant, efficient, and powerful. 703. Knowledge of this brilliant system spread west. Persian and Arab scholars, like the great Al-Khwarizmi, embraced it. In fact, we get the word algorithm from his name. His book on the subject was translated into Latin, and through trade and scholarship. These Arabic numerals, as they came to be known in Europe, slowly began to replace the clunky Roman system. An Italian mathematician named Fibonacci was a key champion of this new system in the 13th century, showing how much easier it made commerce and calculation. 744, but the transition wasn't immediate. Some merchants were suspicious of the new numbers, thinking they were easier to forge than Roman numerals. It took a few centuries, but the sheer superiority of the Hindu-Arabic system for arithmetic and trade eventually won out. It democratized mathematics, taking it from a specialized skill to something accessible to a much wider audience. 815, the invention of this system unlocked a new world. Science and engineering could now advance at a pace never seen before. The complex calculations needed for navigation, for physics, for chemistry all became possible. The Industrial Revolution, the digital age. The device you're rewatching this on right now, Nava, it would be possible without this elegant system of 10 symbols. 845, from a simple scratch on a bone to the complex algorithms that run our world. The story of numbers is the story of human ingenuity. It's a tale of our ancestors staring at the world, at their flocks, at the stars, and finding a way to make sense of it all. It's a language that transcends cultures and time, a universal tool that helped us build the modern world. 9:16, the next time you check the time, send a text, or just count your change. Take a moment to appreciate the journey those little symbols have taken. Thousands of years of human thought, from different corners of the globe, all culminating in the simple numbers we use every single day. They are one of humanity's greatest achievements. Thanks for watching. If you found this journey through the history of numbers fascinating, be sure to like this video and subscribe for more deep dives into the stories that shaped our world. See you next time.